Dear all, hi everybody. My name is Alessio Trevisana, and I am the SDC Verifier Product Manager here at Engine Software. I work on offshore and construction department since 2007, and I was used to calculate special structures for that field of activity. As you probably know, it's truly difficult to handle code checks by hand calculation or even spreadsheets. And this is why we welcome the SDC Verifier as the final tool to complete this task. So, today I'm very happy to introduce you Mikhail Pavel Oleski, a structural engineer at SDC Verifier. We show you how to use the SDC Verifier for optimization of beam plates and welds. Now I give the floor to Michael. Hi, Michael.
Hello, good morning, everyone. Thank you for the introduction. I will try to share my screen. And okay, so maybe short introduction from my side. My name is Michał Oleksy. I work as an application engineer and structural engineer at SDC Verifier. So my everyday tasks consists of working on our consultancy projects, mainly in heavy lifting, structural engineering, civil engineering, and all topics related to that. Moreover, I also help our users with some issues with our software, or how I help them to solve the problems which they encounter during the modeling or analysis. So if you will get ever any questions regarding SDC, or you will have any issues regarding maybe you need some help with your consultancy projects, you can message me on my email. You can see on the screen below. So I would like you to welcome to this webinar again. Today I will discuss the topic about FEM-driven structural optimizations. And maybe let's start with agenda. So first of all, I would like to make some short introduction about our company itself. I will talk about what we do, what software we develop, and how you can use it within your consultancy. And the next topic will be structural verification with FEM tools in general. So we will discuss the possibilities of what we can do with our software, how it can be useful for your project, for the design which you do, and how it can help us after all with optimization of our structural parts and global structure and local parts of our model. Then I would like to talk about general principles of optimization, some theory, some possibilities, what we can do. Next part will be the approach of SDC Verifier. So I will explain general workflow of SDC Verifier, all the steps which we have to do in order to get our model ready, to get the results, and to perform optimization of our structure, what we can do, and also how we can recognize our structural members from within our model. So we have different recognition tools. I will explain all of them. How we can analyze structure according to various standards. So as you know, there are not only the FEM results matters in our analysis, but also the structure should meet some rules and regulations depending on the industry. Then I will explain in detail how to perform optimization within the SDC for all the optimization topics like plate buckling, beam member optimization and weld optimization. I will say a couple of words about reporting, and we will move to the conclusion. So let's start. A few words about the company itself. SDC Verifier was founded in 1989 by our CEO Wouter van den Bos. He's a tutor at TU Delft University in Netherlands. So we have over 55 years of experience in structural engineering consultancy. The most of the project, the scope where we are strongest is the heavy lifting, all sort of cranes, reclaimers, port equipment, but we also work a lot on offshore structures, marine structures, and even some smaller mechanical parts which have to be analyzed with use of FEM. How we ended up with creating SDC Verifier software. As you know, all the engineers always had an issue with a lot of repetitive work, which could be somehow optimized, or the hand calculation or the spreadsheets which were done before. We decided to simplify it, and that's how we found the way to speed it up with our software, which allows you to perform the verification, code checking, and all the optimization and iterations with saving a lot of time during your process. A couple of numbers. So as you can see, we did more than 250 consultancy projects over the past 10 years. We have more than 100 happy customers, and I think this number is growing rapidly all the time. Regarding the software, we have more than 30 people in 3 offices. The headquarters are in Netherlands, but we have also office in Poland and Ukraine. More than 200 companies worldwide use SDC Verifier. I think we have users on all of the continents around the world. The number of users is way more than 1,000 already. We work with multiple industries, as I said before, heavy lifting, oil and gas, offshore, maritime, and so on. What else? We have the software which works as a standalone and also as an add-on to various FEM softwares. Let's move on. In general, why do we use FEM? So in order to speed up the process, as it used to be some time ago, everything was done with hand calculations, maybe some spreadsheets where you have to manually extract your forces and stresses from your models. It was very time consuming, especially for various iteration during your designing process. So every iteration which you would like to perform to optimize your structure took you basically same amount of time as modeling from scratch, because you had to set up everything, then extract forces, recalculate again and again. That's why FEM softwares are so useful at the moment in structural consultancy or verification. What else is a big difference with all the FEM softwares is that we are not only limited to some simple calculations, we can do also model backlink analysis with multiple load combinations, which obviously saves a lot of time during the design process. And moreover, we got the really accurate results where we focus on, so we can find out the peak points in our structure, which is either impossible with a simple hand calculation, or would be very time consuming. Why we use our FEM softwares is the another thing is that we can prepare very complex geometry, including all the details which we want to have in our analysis. We can use various type of elements like shell elements, beam, solids, which depending on the type of accuracy we would like to get at the end of our analysis, we can adjust it. We can also dynamically change your model during the analysis. So in case if you do the first iteration, you can see some members maybe are not needed. You can revise geometry, the size of your structure up to your needs. So you don't have to go back to modeling in different softwares. You can do everything in one place. What is also important, all the CAD software geometry can be imported in FEM software, which also saves times on the modeling from scratch. Another thing which is very important are the boundary conditions, which are possible to set up within your FEM software, such as SDC Verifier. There are various boundary conditions which can mimic your behavior of your structure in different conditions and different load combinations. The next part of the FEM modeling is, of course, meshing. So again, tools like SDC Verifier can help you with prepare the accurate mesh with various tools for mesh refinement. So for example, around the openings or around some odd geometrical shapes where it's hard to mesh it by hand. There are developed various tools which can help you automate that. Moreover, we have broad database of cross-sections such as much different materials, different cross-sections according to different standards and industries, which can be automatically applied to your model and meshed, and your model can be meshed with properties of those cross-sections. So there is no need to waste again time to create your properties by hand. And then during the optimization, you can simply select some properties sections from the database, which should be analyzed within the software, and you will get your utilization factor or desired value of cross-section, which you would like to, which would be the best for your design. Another things are automatic error detection, which automatically can check your model for some errors which you may encounter during the modeling process. But it's not only enough to create your model and get the results. In order to properly design your structure, of course, you have to follow industry standards. Depending on the industry which you work in, there are probably thousands of standards around the world. In SDC Verifier, we have implemented, I think, most important ones, and the database of the standards is still developing, of course, depending on the client needs. Your structure model can be automatically checked if it meets criteria for certain standard, and also you can optimize the structure for exact standard. So you don't have to just calculate the stresses and optimize and do the optimization for the stress or deflection. You can optimize your structure so it meets exact standards from the various industries. When you have your results within FEM, so what we call utilization factor, depending on the standard. So for example, member check utilization factor or beam or plate buckling utilization factor. Of course, worst nightmare of all the engineers is some destruction of your structure, cracks, plastic deformations, or the other way around, over-designed structure. So how to avoid these issues? Of course, it's not only the calculation and the design, as I mentioned before. We have to design our structure so it meets the standards, it meets the requirements which we have. There are maybe some certain requirements from our customers, maybe our internal rules, which we would like to meet, and how to approach it. In order to design our structure efficiently, we perform various kinds of structure optimization. What is optimization in general? Optimization allows us to choose the proper design to get the results which are not too low. So for example, our structure is have enough load bearing to get all the loading conditions, all the for example deformations conditions which we would like to met, and also on the other hand, we shouldn't design our structure which is too heavy. Our utilization factor for members or plates shouldn't be on the low side, so we don't waste too much material on that. So in general, optimization refers to a process of finding the most efficient design that meets specified criteria. But how to do that? We define some objectives. So we establish goals. For example, we would like to minimize the weight, maximize the stiffness of our structure. We should identify the constraints. So consider the factors like material properties, environmental conditions, and all the regulatory standard requirements. We create our model, as I mentioned before. We get our results, which are the basis of our optimization. Then we can perform our iterative analysis with use of various algorithms, tools like, for example, SDC Verifier optimization tool to refine the design based on the performance feedback of our structure. Moreover, optimization helps us to reduce the material cost, construction time. Of course, we can optimize our structure in a way that we use one section. We don't, for multiple members, we don't have to buy the multiple different sizes, which can also reduce the costs. Again, we can also optimize the cut length, for example, during the manufacturing of the certain structure. On top of that, we need to ensure compliance with rules and regulations, and which is a very hot topic now is environmental impact. Obviously, the less material we use, the less work we use during fabrication, during manufacturing of our structure, the better for our company, and we can we can show that we also have less impact on the environment. Let's start with the methods of optimization. So some theory. We can divide the optimization for shape optimization, where our focus is mostly on modifying the geometry of the structure to improve the performance characteristics such as stiffness or stress distribution. And this often involves parametry modeling. So as I mentioned, it is useful if your software allows you to dynamically change your model within the one software. So, for example, we do the first iteration of the design. We can see that some of the members are basically not needed. The stress is very low there. We can maybe change the overall global geometry of our structure, and all of this can be done within one software. And the next part of the method of the optimization, which we can say we have, is the size optimization. And this part involves adjusting the dimensions. So, for example, thickness, diameter, length of structural elements. So that our shape is already fixed. We know the best shape of our structure, the global geometry, and then we can optimize the members, the plates, the welds itself. So this involves our structural elements should achieve the desired performance criteria, such as weight, for example, or obviously we have to maintain the strength. So we need to find the perfect spot. And then we can define the objectives of optimization. So we have methods, and now we define what we would like to optimize. So first of all, I think one of the most important is, for example, weight optimization, or which also relates to cost optimization. With use of analysis, we can and mathematical iterations, we can get the section for our section or plate thickness for our model, which has the best ratio of weight and of the utilization factor for certain standards, static stress check or backlink check, and so on. So we don't need to use manual iterations, calculate all the sections. We can select it can be selected from the database, all possible sections which can be used for the check, and then with use of analysis, we can pick the correct section and update it directly in the model. The next objective, which we can rule, is the rule of minimizing the stresses, but which can, in simple words, how to design our structure so the stresses meet the criteria, but not only that, we can also optimize the structure. We can set up the maximum level of our stress we would like to have in order to increase the fatigue life, for example, for our structure, and so on. And the last objectives which we can rule would be to comply with rules and standards. So, as I said, it's not only about the stresses or deformations. We have also rules which we have to meet. This SDC Verifier optimization tool allows you to perform the optimization directly for example, DNV or ABS standard, where you can perform the plate backlink and choose your proper thickness of the plate which will give you the best ratio of utilization factor and the best weight ratio for your model. Okay, let's move on to how to approach all this theory with SDC Verifier. So as you can see, I have the diagram which shows the SDC Verifier workflow. This diagram is created in a circle because the design is a repetitive process. So we create our simulation, load combination, recognition checks, reporting, and then our clients comes to us with a question. Okay, let's change maybe one section. Maybe we optimized something. We want to change it in the model and recalculate. So what do? We update our model and then we run all of these steps again. With SDC Verifier, it's enough if you set it up once. Then every time with just a couple of clicks, couple of seconds, you can simply update your model and recalculate all the combination recognition checks and regenerate your report without any additional work. So first part of the workflow is the simulation. So as I said before, simulation consists of modeling of our geometry, meshing the model to encounter all the spots. The mesh should be also refined in the areas where we expect some overshoots, or maybe we would like to have more accurate results. So this depends on the user. The approach on the modeling, creating boundary conditions can be adjusted to your needs. There is various of options to apply the loads to measure structure, lot of predefined elements with different behaviors, which will result in accurate outcomes. Then, of course, when our model is set up, we have to apply the loads, which will mimic the conditions of the structure, which is in a real life. So we have developed also very useful tools for engineers, such as automatic wind pressure tool, which can apply the wind pressure to your structure along the different angles. We have also developed the tank load, which automatically calculates the pressure on your tank. Also wave load, which can be applied for all kinds of offshore and maritime structures. Going back to our diagram, after our simulation, the model is done, we have to prepare load combinations. So how we approach it in SDC, we divide the load combination in SDC for basically 3 different steps. So first we create the individual loads, as I mentioned before, which are combinations of individual load and constraints. Then we create the load sets, which are the linear combinations with safety factors, which you can find in various standards. So for example, EN 13000 Eurocode, or for example, American standards. As you know, there are always different groups, different conditions, different load factors, which should be encountered. So there is also several ways to create those combinations in SDC Verifier. First of all, you can prepare everything with use of Excel sheet and just simply copy and paste it into SDC Verifier. Or we have also a tool to prepare the automatic combinations, for example, to Eurocode or EN 13000. You just have to set up the category for your load, and your combinations will be set up automatically. I've got short video also how you can quickly paste your combinations, for example, which you created in your Excel sheet, to simply copy, Ctrl+C, Ctrl+V, and all the combinations are ready to be analyzed, and you can get your outcome to perform the check analysis. The next part is the recognition. That's, I think, one of the most crucial things before we start optimization of our model. So with SDC, we can recognize joint members within our structure, beam members with all the backing lengths. SDC automatically recognize the joint connection, as I mentioned before, with both directions of each beam. So your backing length will be directly read from the model, and then it can be used to get proper results. Also, it doesn't matter how many elements you have on each beam, SDC will recognize it with use of all the joint members. Another thing is the recognition of welds. So SDC can recognize the welds within your model from the shell structures or also from the solid elements. This can be done, of course, or they can be used, of course, to perform various weld checks according to different standards, and then, after all, also optimize the weld sizes. Another part of the recognition is stiffener recognition. So all the beam stiffeners which are modeled within your FEM model will be recognized. Each of them will get the separate ID number, which also allows us after to easily recognize which element is which element has certain utilization factor, and pick only certain members of our model which we would like to optimize, so we don't have to do it for full structure. Also, this also saves times. The last thing is the plate recognition. So SDC automatically recognize the plate sizes, the thicknesses within your model, and all the various parameters which are used after all for the checks. Then the checks itself. So to get your utilization factor in SDC, which we can process after all, we have developed a very large database of different checks according to different industries. You can see they are grouped in SDC for the industry, for the type of the check. As you can see here, as I showed before, we have more than, I think, 46 standards at the moment implemented, but that's not all. Any of the standards can be edited by yourself. You can create your own standards. Also, depending on the company, we can also help you with to create the certain standards. So your optimization don't have to be performed only for the industry standards which are predefined. You can do it also for your simple rules. You can write simple scripts, a simple equation to show, for example, just the utilization factor for stress, so stress more than certain value. And you can also optimize your structure with use of this check. So it don't has to be any predefined check which is already in SDC. Okay, when we have all of our results, then it's time for optimization. As I mentioned before, in SDC, we divide optimization for, I would say, 3 different chapters, 3 different groups. First of them is beam member optimization, which allows us to optimize our lattice members, chord members, braces, joint elements, and so on. So how does it work? You can simply select the member which you would like to optimize. It don't have to be even the full member. You can optimize only certain elements of the member. Then you choose possible beam sizes, which you would like to take into account during the analysis. And then we will get the results with utilization factor. I will show it slightly later, how it looks in practice. Then next group of optimization would be plate and stiffeners optimization. So as I mentioned, it's crucial to properly recognize your model, to recognize the structural members of your model. All the checks are not done on simple finite elements, but they are done on the members. So here, for example, for plate buckling checks, we can select the plates which we would like to optimize, choose the possible plate thicknesses. We can select, for example, the range from, let's say, 8 to 25 millimeter with some step of thickness. And also we can optimize our stiffeners in one go. In order to do that, we have to also select possible shapes of our stiffeners, which we would like to take into account, because as you know, not all the shapes probably are good, depending on the company rules or on the manufacturing plant rules. We can also help them to choose the proper sizes which are easiest, and not only for the which work the best not only for the structural point of view, but also in terms of manufacturing. The last type of optimization is the weld optimization. So here, again, to properly perform the weld optimization, we have to recognize our welds in the model. SDC not only allows you to recognize the weld itself, but you can also preview which part is welded, which part of the model is non-welded. Then you can set up the desired weld type. So for example, fillet weld, partial penetration, full penetration, and so on, to certain weld selections. You can predefine the rules, for example. So my weld throat should be minimum 1/3 of plate thickness, maximum 2/3 of the plate thickness, and so on. Or you can also just simply choose the desired size which you would like to check on your model. Moving on, how it works in practice. So in order to get the results, you simply add the standard to your model, to your analysis, fill some data, which has to be assigned by engineer, depending on the standard. Then we can preview the results with use of various plots or tables. The results can be previewed not only for full structure, they can be previewed only for certain beam members or certain elements. Another thing is that we can choose the load group for which we would like to show our results. So it's not only for, we don't have to only show it for a certain load combination. We can also perform the optimization for single FEM loads. Let's focus on this example for plate buckling. As you can see, we have some plate backing overshoots of utilization factor. Here on the right hand side, you can see the legend. So all the plates with colors of orange and red does not meet the plate backing criteria. How to optimize it with use of SDC? Once you are in SDC window, you can find the optimization button in your model tree. By right-clicking on it, you can simply add the optimization rule, and you will see the window where you can create different type of rules. As you can see, there are beam element rule, plate backing, just plate element rule, or weld strength rule. Here, if we start with plate backing rule, you will see the optimization tool window where it's possible to choose again your load group for which you would like to optimize your structure. And then there is a window which allows us to select the parameters, limit parameters, which should be considered during the calculation of optimization. Here on the right hand side, we have possibility to choose the optimization variable. So for example, plate thickness, we can optimize not only by plate, we can optimize also by our material. So for example, yield strength. And also we have possibility to choose if our variable should be optimized by minimum or maximum value. Then when we select our parameters, you will see all the possible checks which you added. So the more checks you add in your model, you have calculated checks, they will appear here. Sorry. Then simply out of this list of check, you can select the rule which you would like to optimize. And on the right hand side, there is a list of all the parameters which are calculated in the checks. Here, I selected the utilization factor. And here you can also select directions. It is also possible to set up limits. So for example, I would like to keep my utilization factor between 0 and 0.9, for example. The next part, as I mentioned, is to choose the variable. So we can optimize by plate thickness, Young modulus, or yield stress. And then how we create the selection of our plate. So the user has the possibility to choose the correct plate which you would like to optimize. So again, it don't have to be done for the full model. It can be done also for certain plates. Then proper selection of the possible thickness. So all the thicknesses which should be analyzed within our model, yield stresses, and the Young modulus. Then after the rule is added and it's calculated, user can preview the results. So as you can see, the results of this plate element, which can be updated. The original model was 6 millimeters, and the proper plate size with 10 millimeters gives us utilization factor of 0.93, which can be updated directly from the optimization window. It can be updated directly in the model. So there is no need to manually find the property, change the thickness. It can be with one click, it can be updated within your model. And then the only thing you have to do is to reanalyze your model and update all the checks. So as you can see, this plate was optimized and the results are now within the allowable limit, so under 1 utilization factor. The next rule for beam members works in a very similar way. The only difference is that instead of plate thicknesses, we choose the shape cross-section areas, as you can see here. So when you choose your beam, which should be taken into account during this analysis, the optimization, you can select proposed sections from our database. You can also use some custom sections, create your own ones, include it here, and then SDC will perform all the iterations, giving you the proper results for each of those sections. So as you can see, we can find easily which section has the highest possible utilization factor. So if I selected that my factor should be between 0 and 1, that's the highest, the smallest section which is possible to, which could bear this load according to the standard. And the next and the last rule is the weld optimization. So as I said before, after we recognize our welds, create standard to get our utilization factor for all the welds in one go. It is possible to create and preview all of them in one plot. You will see the results and you can find out which welds should be optimized from here. Then again, simply adding another rule. Window looks very similar to previous ones. Again, the difference is we don't choose the plate thickness or beam sizes, but we choose the possible weld types together with possible throat thicknesses, or we can set up also the rules for our weld which we would like to meet. And again, we can choose the weld directly from our model by just simply clicking the pick by element and then simply click any element of the weld which we would like to analyze, or you can also choose by list or different, there is plenty of other ways how you can select the certain weld here. As I mentioned before, there are possibilities to use full penetration, partial penetration, and fillet welds within your optimization rule here. Again, you can preview the results, the most optimal results within your model, and directly with one click update it directly in your FEM model and reanalyze to get the proper results. So as you can see, this weld was optimized, so now we have utilization factor less than 1. On top of that, as I mentioned before, after all of our optimization, of course, we need to show the results to customer or maybe internally. With use of SDC Verifier, it is possible to create template for the report, set up all the views, all the possible iterations which you did together with cross-sections, properties, all the plots of static stress checks, utilization factors, and all the steps and explanation of the optimization you did within your model or the iterations. You can create the report and with one click update it every time when you change your model. So summarizing, the optimization is one of the most important parts of the structural design, because even if we have most sophisticated FEM tools which can give us great results, you can prepare your model with all the details, then you simply get the results, whether your structure passed the certain limits, rules, or no. In order to properly design your structure, it is important to optimize it, choose the proper sizes, don't over design, save the cost. So all of these factors are desired within the analysis. So summarizing, integration with your model is the key. What does it mean? So connectivity of your optimization tool within the model is one of the most important things, which can save your time. Just switching between the models, between the softwares, it allows you to enhance efficiency and, of course, reduce the design process time. Another thing is performance and safety, which leads to improve the safety, the performance of your structure. You can design it just as it should be, so no over design or under design. Then it leads us to cost effectiveness. So no over designing our structure means that we save money also on the manufacturing. Maybe we invest a little bit more time during the design process, but at the end of the day, the cost of the whole project will be significantly reduced. Another hot topic is sustainability and the environmental impact, so optimization, of course, allows us to reduce the size of our structure, the amount of materials, and also sometimes amount of workflow by redesigning the global geometry. Then, of course, we reduce the impact on environment and again reduce the costs. Innovation opportunities with use of FEM tools and optimization, we can design the structures which most likely would not be possible to be designed by hand calculation, or it would take enormous amount of time, which would lead, of course, to huge usage of resources. And with use of quick FEM calculation, the time can be saved, and we can drive our structure to the maximum, which allows us to invent new designs, new geometrical rules. Also, different industry adoption. So this can be used, of course, in all industries, not only, let's say, structural engineering or civil engineering, also mechanical, offshore, and maritime. And then future potential, the rules, the softwares are still developing, and every year there are more standards which are implemented, and also this can be improved from time to with the time. So I think that's all what I would like to what I wanted to show you today. Of course, if you would like to test our software, feel free to contact us. If you feel you don't have enough knowledge, enough power to make your consultancy project, you can also reach to us. We can help you with use of SDC, to optimize your structure, to get the proper model, create the proper result, get the proper results. So in case if you have any questions, feel free to contact us. Again, we can also provide you with a trial license, which can be used to evaluate how SDC works and how it can be helpful for your company. Thank you very much, and I hope this webinar was informative for you. And I think if I would like to ask if there are any questions. I think now it's the perfect time for that. Let me see if we have anything in the chat. I don't see any questions. If you have any, please feel free to unmute yourself, and I'm happy to answer any doubts.